Yeah, recording this Revit basics, but most important, laser cutting and stairs. Very basic introduction. So let's hide this thing. Okay, so as I mentioned, we are whatever this is at the given moment. So we need to find that kind of a bold element. This is the 3D where you go when you go to the doghouse. I call doghouse because it looks like a doghouse, very cute. There is a shortcut for other elements, but you know. So when you go to that view, you're given a number of things that might be like, what is going on? I don't understand here. A thing. So there's this thing that's called the section box. I don't know if you've been introduced to the section box. The section box, when you're in 3D and you do not select anything, you can go down and there's a point here which says section box. We're talking about the properties panel. If you uncheck that, the section box disappears. If you check it, it appears. The section box, it's a marvelous tool that allows you to move these little arrows and it cuts the building, whether it's horizontally or vertically, you can cut the thing, okay? You can definitely select it and hide it. And I'm not gonna talk about those basics of how do you hide and unhide. I'm sure you have been introduced to that by other professors, but there's a bunch of items here, it's like the glasses to hide in and hide. Temporarily, you have the light bulb to turn on everything, and then you have the right click hide options here, category or elements. So you have many things to hide. Again, if you go back to section box, what it would do is just uncheck, it would just go back to the original state. We also see this little rectangle, which sometimes could be annoying. That's actually what is called the cropping region or crop view. You can say, yes, I want to crop, or no. Notice here on the edge how when you say don't want to crop, you extend any item from the model beyond that point in terms of visibility, or you crop it. But you could also say, well, I don't want to see the cropping view. I want to hide it. I want it to crop, but not to be visible. You can say also, I don't want to crop, and I don't want it to be visible. What things can we see here? We see one of the most important things from Revit is these items here. They're called, you got it, levels. And there's a number underneath. That's clearly the position of the level. A level, it's an infinite abstract plane that lives in the surface that we step on as humans. The classic question sometimes is, well, if I'm doing a little section of my project, you know, yeah, people are coming there, but it's not the whole floor. Well, it is a place where people can step on. That's called a level. You might create it. But even if people cannot step on, maybe you have a particular item protruding from your wall at a specific height level to, for example, block the sun from coming in. And it's a horizontal item and it's quite prominent enough for you to use levels. You create a level, you might not call it 2 or 3 because it's not actually you know, humans are there, but you can call it level, you know, solar machine or whatever it is. You know, you can give names that are not necessarily the numerical order to refer to where things are. So in general, that is just signaling to where the different floors are. The best place to see the levels are not in the 3D, are typically in sections. Everybody understands that. Sections are generated with this little guy, section, or you can also go to view, go to section. You can create as many sections as you want. The second you create a section, a new drawing appears in your project browser here under sections, and their name numerically 1, 2, 3, 4, 5, 10, 100. But you can right click any view and say, I want to rename this. You can call it Pepito if you want. It's up to you. Typically sections are numbered or letter A, B, C. So the reason why there's nothing here in terms of information is because there will only be something here when you put a section into a sheet. This is more advanced. A sheet is, let's call it like the paper space in AutoCAD, where you can have a dimension of a white canvas and you can drag the views from Revit directly to that white page and set the scale in a very easy way compared to AutoCAD. The second you place a section into a sheet, this guy knows, oh, the section is in sheet A3, and he will have here A3 and the number of the section. And that's why these are great for CD, like construction documentation, because it links all of the views together, no? And that's what we need to do when we submit to the Department of Building a construction documentation or any document at all. But when it comes to a presentation, maybe an early presentation to a client that you want to convince them about the powerful ideas that you have, maybe these symbols are a bit too, let's call them construction driven. No, it's a bit, you know, the triangle, the circle, they're heavy in nature. They're a bit clumsy as well. I mean, they follow the standards. That's why they're great for bid submissions, et cetera. But again, so maybe what you could do is say, I want to hide these guys. Again, there are different ways of hiding category, and you don't see the sections, even though you have the section, no? That's one of the sections. It's another one, et cetera, et cetera. You can hide those, and then maybe you extract, and you've probably seen that with Will, each of these views as a PDF or as a DWG, whatever it is, and you can take them to Illustrator and then clean them up and make them beautiful if you want to have a powerful, elegant presentation. And in Illustrator or in InDesign, you add the section mark. Beautiful, carefully crafted section mark. Or in AutoCAD, by the way. And not a clumsy orthopedic type of section mark. But that's more aesthetics. Okay. If you go to the light bulb here, it shows everything that is hidden. Sections I just hid and unhide category to get them back. It's a little bit of a process, but that's what it is. These things are called elevation symbols. It's a triangle that indicates looking to the building. And here's where we'll say this elevation is in sheet A23, architecture 23. It will appear there if you're dragging to a sheet any of these guys, elevations. Elevations can be double click and you see the buildings from the side. Okay. In elevations and sections, you can see the levels. The first lesson I'm sure Will has taught you about is the idea of how you create a level. Or how do you move or transform a level? That's fundamental. Well, I'm not really going to do it here, but it would be as simple as asking yourself, I want to change the level. So you click on the number, and instead of 12, you say 13, you press enter, and it will shift. Good and bad things. I think it's good mostly. Everything is linked to each other. That's why the information modeling. So if you move the level position or height, it might be, most probably, the floor is linked to the level. So if you move the level, the floor moves with it. And oftentimes, if not always, Revit's going to tell you, wait a minute, you just changed this, that is changing that is changing that as well. Be careful. Say, I don't, or you care. You can move things manually, obviously. But maybe, given that it's a bit more of the building information modeling logic, you might want to click on the number and change it or select something, and you have all of the modifying options, move 3 feet above, whatever it is. You can create levels by going to architecture, levels, double L. Shortcuts in Revit are 2 letters, opposite to AutoCAD or Rhino, which is 1 or 2 letters, and then enter. You don't need to press enter, just 2 letters and you're good to go. And then you can create another level. The second you place a level, let me place it here. It renumbers it in order. It knows that 4 was the last one. You might want to level in between. It's going to call it 5. You might not like the 5. You can click also on the text and call it Revit. Why is this being asked? Well, as I mentioned before, when you create a level, automatically a floor plan appears because it's the potential for a floor to exist. You might not want to put a floor, but the level exists and the floor plan potential exists as well. There is 5. Okay. So if you double click, what are we seeing here? What we're seeing is a plan of the model cutting 4 feet above this plane. That's the standard in building plans. So what it does is automatically creates a floor plan level with the title and the name that you have over here. And when you go to it, double click, it is cutting 4 feet above looking down. So if I go there, this is 4 feet looking down. Automatically creates also a ceiling plan. Obviously, if we have a floor plan, it's also ceiling plan. Level 5, it is automatically cutting your model at 7 feet looking up. My gut tells me that, obviously it's going to be cutting outside of the building. It's going to be looking up. Not much we're going to see, if anything at all, given just the logic of where the level is. Does that make sense? So we're just cutting above the building, looking up. We don't see anything. We could have the clouds here, but we don't. So as I was saying before, you can just click, not only change the number height, but click on the name and say again whatever you want. And the question is, well, do you want to rename the level from the project browser? You typically say yes, but sometimes you could have a name here for a level Pepito, but have it here as level 5. Could create issues, but it might be good for some settings, let's call it. Okay, so I'm gonna say yes. And here is level Pepito, okay? Okay.
I don't want a rectangle, how do I change that?
What rectangle?
Let's say I want my floor on another level to have that angle, how do I change it?
What angle?
Like, so I want to chop the corner off.
Okay. So how do we create things? And this, again, is more of a wheel thing, but let's do it. I will just talk about the ABCs of creating something in Revit, and it's different for each of the things that you want to do, but typically it follows similar criteria. There's the things that go up in a way, and the things that are like this. And I'm talking of project elements. Project elements are not items that come from another planet and land into the project. Let's call it furniture or a light fixture, or things like that. Those are called families. Those are things that you have another platform in Revit that you can model them, save them. You can download them from the web and say, I want this thing landed into my project. Those are families. So I'm talking about project items, which are things that relate to the project, and that they don't land from outside. They actually are defining the project itself. And that's walls, floors, roofs, ceilings, things of that nature. A door is a family, comes from outside. A window comes from outside. Even a structural column comes from outside. All these things come from outside. A railing and all these things. The stairs are a bit more complex. They depend on 5 or 6 or 7 different families coming together, like the railing family with the steps family, with So the landing family. So there are a number of families that shape a stair. So it's a bit more of a complex thing. Okay, I'll just say that walls, things that are vertical, when you create them, you probably want to be in the plan, but you can be wherever you want. And then you click on wall, and then you just have to think almost intuitively what is the information that we should tell Revit to use in order to create something that goes vertically like this. And if we just think a little bit outside of softwares and I think, well, you definitely want to say, well, what type of wall? So what are the layers that make that wall? How thick it is, that wall? You know, is it brick or is it sheetrock? What is it about that wall? So that's this properties types. And also you say what type of wall. You have many of them here that you can select from. There's some interior and there's always some exterior. And definitely there's a way to generate your own type of wall, which is editing one of the existing ones and adding another layer or making it a little bit thicker, whatever it is. This is editing the wall that I'm sure we'll talk about if it hasn't already. So the type. And the other thing is, again, if you close your eyes, the thing is like, okay, from where to where? So how big, I guess, is the thing, no? So it goes from here to there and from here to there. So how do we do that in Revit is typically from what level to what level it goes. And there are many items that you can use in terms of how do you create it, but in the most important one is basically here under the properties, the base constraint from where to the top constraint to where. So those are the two things. You can do that here in the properties, or you can say here height from the level I am, which is level 2, up to the level 3. That would be the way to say from here to there. Together with the type, you draw with any of these options. You can draw a rectangle. And again, it's different than AutoCAD. So rectangle is not a line. It's actually a set of 4 walls shaping a room that is rectangular, and the base of that room is level 2, and the top constraint is level 3. You can do polygonal shapes, you can do polygonal, you can do circle, you can do arcs, you can pick, those are things that are, just picking things that exist in there. What you can't do with this system is spline-driven walls. Okay. You can also have some tangents, like for example, if you click this option, you click at the end and you can create a tangent, and tangent, tangent, and so on. You can also do what is called a fillet. Fillet arcs allows you to select 2 edges and create a fillet of the wall directly by clicking 2 elements. No? Which is a great tool. This is while you're doing the wall. So there's not really a fillet command in Revit. There is I'm doing a wall. I would like to create a fillet wall. That's how I worked, okay? So you might not find it easily if you're thinking AutoCAD driven methodologies. Well, that's only the walls. So the thing about the walls is that obviously I can get to this, the 3D. If I turn on the section box, I just want to see that wall that I just created. Here it is. So that's the thing. Just a reminder, all down here are the things such as scale. There's the way you see things in terms of style. So you can do shaded, et cetera, wireframe. So if you want to see through it, wireframe is a good idea. I typically have it hidden. We'll talk about the solar studies, which are here in a matter of minutes. So then notice how we say that this wall should go from level 2 to level 3. Level 2 lives again on the top of this floor, and level 3 also lives on the top of this floor. That's why these partitions are going through the floor and meeting the top. So there are ways of, you can systematize this idea that they go below, but I typically just do it afterwards and say to some of the partitions, hey, you, I want you to be what is called attached top of all to the base of this floor, and then they go down. So that's something you can do. Just bring down the partitions. That's a good way to do it, is that you have attached to base, but you can also do the classic numerical. You select the partition and you know the thickness of your floor, and you say top, constraint, offset. So I say minus whatever, like 1 feet. Apply, and it will, oh, this is the base constraint, sorry. The top constraint, here is top offset, let's say -1 feet, and it will come down with apply. So you can do that as well.
So when does the thickness of the floor get defined?
Correct. So that's wall world, that's vertical stuff. What about horizontal stuff? Well, the best place to do any floor, it's on the floor plan. There's the floor component. When you do a floor, well, the first question is exactly the same. Well, what type of floor? So you have several types by default, but you might want a new one. I'm going to select this one for now. And the interface looks slightly different. There's an X and a check. But the drawing items, by the way, when you start a wall, when you start a floor, when you insert the door, the whole top bar changes, and it's a little bit confusing sometimes. What did you change my set of tools? Yes, I changed it. And at the beginning, you get a little pissed, like, why are you doing that? Where am I? So just think of an editing mode or creation mode. It lives in a different kind of a tab, so it just changes automatically when you do something. And they're just the idea, again, vertical things won't have the X and the check, but they will have the what is called the draw options here, because you're drawing where the walls are. But with floors, it's different. It's a bit more of, hey, first, draw the perimeter of the floor, and then say, check, you're done. And it creates the floor.
You did all that for us, like creating that model, you're like, I'm going to do the floor, and you put all that in. That's great.
Yeah, well, the site is there from, I think, from Martha's last year or so. Yeah. So you will do a floor, let's say. Floors during this creation moment are just thin magenta lines. Okay. When you're doing a floor, it should be a closed polyline system. So if you have an opening like that, no matter how small it is, and you say, I'm done, I'm going to do a floor here, it's going to tell you, you're not done. Lines must be in a closed loop. Say, yeah, that's right. Continue. And then you can either take it up there, do whatever you want. Once it's closed and you say check, there it is. Where does this floor live? Right now in space, but in level 2. So if I go to the 3D, there is in level 2, floating around space. Okay. You're welcome to select any floor you have created and either double click or edit boundary. You edit the boundary, goes back to the creation mode, and you might want to edit this thing. For example, with the TR being trimmed, I can do that. No, I'm editing the profile of the door. So step 1, if you're modifying the existing floors, you need to select it. Now, sometimes it's tricky. What do I do to select? The wall is here. What is going on here? This is what? No. So sometimes what you can do is select a bunch of things and filter out things and say floors. And then before you do anything, just check that this, oh yeah, is the floor that I want to edit. And then you say edit boundary. And then you do your work. You can see where the line is and say, well, I think it's here. No, so you say, well, this is the line. Obviously, you can have a line in the middle. If I say, okay, it's going to say, no way, this is not a closed loop. So you say continue, and you can do some modifying work. I'm doing trim, TR, to trim the work. But notice how there's a couple lines there. That would be a problem for you. You can't have things. It has to be just a polyline that is closed. So then you can say, okay, and there you have an opening. Okay. You can edit it and edit it and edit it and go on and on and on. You can change the type of door that has been created, et cetera, et cetera. Another thing you can do with floors, which probably is useful for everybody, is that you can say, well, there's actually an opening where the stair is going to be. And if I can do what is called a split here in the middle and TR to create that situation where the polyline is coming in here and doing that shape, so then you have an opening in the middle. You can also do any shape in the interior of that polyline, whatever shape it is. If it's interior, we'll do a donut cut. Okay. Obviously, if you go to the sections, those things will be them shown. Just this thing. Oh, okay, no, that's nice. Good. Notice how the partition I did before going up there. I wouldn't recommend you use much of the arrows to take things down because that's kind of a, it's not really, anyway, you could do it if you want, but just be careful because it might give you some problems. Just think of what is the thickness of this floor and then take it down that dimension or do the attach to a base to take it. No, it is. If we take advantage of what's best about this program is the numbers. So if you start really modeling the way Rhino works, which is a bit more like organically, you might, it's not, nothing's going to happen, but you're not controlling the dimensioning of things. You're starting to, like, for example, let's say I take this down. There's a lock thing. Do you want to lock it to the bottom? Yes, no. Say no. Then you change the level and you take it up. Then the wall doesn't go with it. So there, I guess, it's like with some drugs that you have after, you know, type of things. So you have to be careful with what might happen later on down the road, given some of the. I would try to be as numerical as possible. And that's good practice. Now, of course, if you're doing more of a sketch model, maybe you can be a bit more organic. But if you're doing more of a later phase of construction zone, I would be very specific about the numbers that define things. Okay. Needless to say, you can obviously, just pop up a camera anywhere. That's a great place to work actually through camera views. I would place a camera sooner than later and say, well, what is going on here? And you can edit using the view of that camera. You can select the floor, edit the boundary, and you say, oh, I see. And then you can go to the level 1 to edit it. So you can select things. And you're also giving yourself an opportunity to see the thing, and criticize it as you're developing, which is good. Notice how many windows open. There's this click I like is the close inactive views. That's when you have 1,000 windows of the same project. You can say, well, just let's close this because I don't know where I am. And it doesn't close all of them. It just closes everything but one. So if you have other models here, they will be there. But every single model open in Revit will have only one view. It clears things and it kind of organizes your thought again because it's easy to get lost when 1,000 windows are open. I create a camera that is under the 3D views. You can double click on the 3D views and then you can go back to that. It's good to see things in scale, I think. So what you could do is add a component that's a 3-dimensional component, CM shortcut that is for objects or things that they're not a standard family elements. So you can say component, and hopefully we have people here. There's trees. I don't see people. So you might need to load families. This I'm sure Will has talked about. Under insert, one of the newest thing is that you can load Autodesk family items. I don't know if you've talked about this, but there's a bunch of families that are standard to Revit, and you can find them now on the web. Before it was a folder, it was a nightmare. And you can just search for things that Revit has for you to use, three-dimensional or two-dimensional. For example, columns, furniture, lighting items, lighting fixture, entourage, that would be like the people, for example. If you click here and say load, it feels like nothing happens, but when you go back to components, by the way, this pops up all the time. I would recommend you save it. And then those things that I downloaded are actually here. And you can select Florence and place Florence at a given level. I don't know what's popping up there. Maybe it's better to go to level 1 and place Florence there. So when you go to the 3D view, there's our friend Florence. Okay, now notice how Florence looks a little crappy here. It's because it's two planes. That's how back in the times the people were done, and it's basically a plane that a photograph of Florence is placed. So, and it's two planes. So if it rotates towards the camera, it's a little weird thing. So if it rotates towards the camera, you always have Florence, no matter where, smiling to you, which is great. So that means that if I go here to realistic, Florence will be there, looking at the camera or doing her thing. So then I can navigate around and they say, Orbit, hey, Florence, don't go. She's always going to be there. Okay. Now, if it's a realistic rendering, it will look like that, more or less, better in terms of light and so on. If it's, unfortunately, perspectives that you might want as line drawings that you can do, just export as a PDF, Florence will look like this, as you see it. So you might want to work in Photoshop or Illustrator to do those things. The wheel here allows you to look up and down and do all these things that you can imagine and do in terms of three-dimensional perspective. So, okay. But this is, again, probably I'm thinking now is a better way to select things to see the space as you're modeling, et cetera, et cetera. Let's do what we are meant to do now, which is let's start stair very fast. I want to do a stair from level 1 to level 2, and I'm going to do a very simple one. One of the first problems with Revit is that I can't see the things above me unless I go to the level 2. Then I can see level 2, the openings of things, you know? But I want to do a stair from level 1. That's kind of the way I recommend you do. There's a feature in Revit that allows you to see things in other levels at the same time as where you are in. So you can go to what is called underlay. Underlay allows you to say, I want to see level 2 here. And you will see level 2 from level 1. I will be careful. And as a reminder, just try to turn off underlay afterwards when you're generating the final drawings, because underlay is a bit of a gray line of something else that might be disturbing the actual plan definition. So I will call underlay it is very helpful to work with underlay, but it's not adequate as a final presentation strategy. Okay, you can say look up, so you can change the underlay settings. So now I'm seeing the opening from level 1 that I have, which is great. So stairs are, here, stair, and it's a bunch of things. Probably will talk or has talked already, and it's the idea of a straight. set of stairs, there's the spiral stair, there's the center end spiral, there's the L shape, but with, you know, the diagonal. Um, if you need to kind of save on some spots and dimensioning, there's the U shape, but also with using diagonal systems, like in the spiral systems. The most common one is the straight stair because it allows you to do several types. So think of straight stair as the 90% of the time you're going to use it. Sometimes you will do a spiral stair. It's a cool thing to do. Straight stair works the following way. Number one, you need to be in the base level of where the stair starts going up. And number two, you need to decide what is the thickness of that stair. So now most of you are introducing the 3 feet because it's the default stair in Revit. But unless it's a secondary private house type of thing, basement stair in a house, I think 3 feet tends to be small. So I will probably revise this and really question that value for the stairs that you're doing. So in more of a public setting, 4 feet probably will make more sense. And given them, you're gonna take probably a lot of people up to that community space, to that restaurant, to that cafe, to that art center, whatever it is, you might want to consider a 4 feet width of the stair. Revit calculates all of the steps, risers, treads that you need according to the standards set by the code here in the States. So if you want to change that, you need to go into a bit more of a calculation and set the number of risers and define that. That is very useful when you're representing an existing stair of an old building. Existing stairs of old buildings, they don't follow code, but they are there and they need to be represented. They might not change at all in the project. So you need to say, I don't care what the code says. I need 20 risers, not 21, sorry. So you do that and you change the basic standard options, which are here. Okay, I'm gonna leave the code and let Revit decide for me. The way straight stairs go, you start by clicking once, it starts as I move the mouse towards the end. Notice how the risers changes as I go. Those are the vertical planes of a stair. They're called risers. They're moving on and on and on. And I could do a straight stair. And that's it. Let me escape and put it actually in the middle. Okay, I finish and I say it's a straight stair. Why not? Once you're done, you say, okay. And you're done. The representation of the up symbol, the cutting symbol for the stair, and dashed lines above the cut, continuous line below the cut with the up text signaling how you go up. So all of the representational standards of a stair are automatically set. I forgot to say that when I was doing a stair, there are 3 types of stairs, the same as there are 3 or many types of walls and floors. There are, generally speaking, 3 types. The assembled stair, the cast in place stair, and the precast stair. Assembled stair, it's typically either metal or wood. That means that you assemble it in situ. So you bring the pieces of wood or the pieces of metal and you drill them or you nail them or whatever you're doing on the spot. No? I mean, you could have an assembled stair that is fabricated outside of the construction site and brought in already assembled, but still is an assembled stair. Cast in place, that's basically a concrete base there that is cast in site, on site. That means that you have a typically wood framing container and you pour in the concrete and you wait some days, it hardens, You remove the framing of the wood and you have a stair that's cast in. So you pour in the liquid that solidifies and you end up with a stair. And then the precast, basically outside of the side in the fabric or whatever it is, they do the pouring, the so on. They put it in a truck and they bring the pieces of the stair to you with a crane or whatever they place it. It's more detailed and more carefully designed and fast to install, but more expensive because of highly qualified workers are involved, high and expertise of a company, et cetera, et cetera. Okay, so those are the three. Each of those will definitely have a different look in Revit. So when you say, okay, and if you go to our 3D, let's go and take a look at the stair. This is the stair. This is actually a stair. By the way, when you're moving around, sometimes it's difficult. In Revit, it's selecting something to orbitate around that something, which is quite useful. Otherwise, sometimes it's difficult to. So there you go. We could even go to the camera probably and see what we see there. Where is the stair? So that is a sample stair. Each stair has its set of families, as I mentioned. So you can select the stair itself, and you will be able to see in edit type a number of items that you can choose, the run type, the 2 inches tread, 1 inch nosing, 1/4 inch riser, non-monolithic landing interior, right support. So those are the supports. If you say stringer, carriage, whatever those are, the items that you can start adding. That would be the right support, the left support, what type of support, blah, blah, blah. So you can edit each of the components of the stair in different ways. If I select the stair and I change the type to monolithic, it will look more like concrete, as I mentioned. If you change it to precast, looks very similar, just a little bit bigger width. Essentially, they're both made of concrete. On top of the stair, there's these things called railings. Railings is another family. Railings, you can change the type of family and automatically change whether it's a handrail, whatever it is, and the type of handrail. You have around 4 or 5 options. Beyond that, if you want to be specific, that's when problems come, because Revit has the standards. And maybe you can download from the web some other families, but that's the lack of creativity maybe that Revit doesn't serve as well. There are two railings, you can change each of them. You can also eliminate the railing, it's just deleting it. Railings are automatically assigned to stairs. You can create your own railing, whatever level. Be careful when you click in the level 2 ceiling versus the level 2 floor plans looking up. You can create a railing of your own, different types of railings, as I said before, and clicking through the spaces that you think they're railings, okay? Railings have to be created as a continuous polyline, not necessarily close. If you're missing a point, it's going to tell you, well, you're missing something here. You can add the railing to have that continuity. Otherwise, you do one, yes, another one, yes. When you go to the 3D view, we have railings on top. Okay, those are the basics. Just to let you know, what time is it? What am I doing? Yeah. That when you do obviously stairs and straight line, you don't necessarily have to do the full straight. You can stop at a given point and create another set of steps. So you have that option. You definitely have the U shape with a landing option. There's a point where before you say, okay, you can move these landings, MV for moving, and put in whatever you want them to be, and the landing adjust. So you have those things. The stairs, you can do the spiral option, also different types of them in terms of materiality, and then you can say, well, how big it is, how small, and say, okay. That also creates the representation of that element. You have also the spiral with the center, so you can say, well, it's that big, more of an arc element. I could say, well, half of it, and then continue that and do another landing. So basically, there are many types of stairs you can do. Beyond that, and that's probably a Will's job, but you can always edit a bit more the stairs. If you edit the stair, there's a way of changing the landing to what is called a sketch base component of a stair. That's again something for you to talk to Will. But if you convert a component of the stair, it makes it what is called again sketch base. You can't go back from that, so be careful. And now you can edit this, edit the sketch. It brings out a green line, and this is similar to floors. What you could do is any kind of shape, as long as you have a closed polyline, for example, for that landing, it will redefine the railings following that curvature. Yeah. Okay. So I know I'm going too fast. I think we should be covering all this, but again, you can change some of the components of a stair and make them a sketch base and transform some of the sketch in options. So again, that's edit stairs, select the component of the stair, for example, that one, turn it into a sketch base, that turns on, the green line appears, and then you can do some very minor modifications. Let me see if this works. For example, that if you turn on and I know that the extension of these lines or the risers go, then you can do a stair following that profile. So there's some variations you can do to a stair, but again, it's quite stiff in the possibilities. Okay. So to Rhino, from here, you need to be in the 3D world, and you need to have the things that you want to have. So I want all of these things to go to Rhino. They should be there. If you don't want some of those, right click and hide, and they won't come to Rhino. The way to take things to Rhino is File, Export, CAD formats. CAD is the language because CAD was one of those first programs. So most of the softwares out there speak the DWG language. So, oh, I didn't see it. Here it is, DWG. This that you see in this window is the thing that you get later on. Now, before you send it, by the way, you can add more stuff later on, but you can say 3 points. And there's one thing, a list that I would like you to take a look at is these are the layers that will come into Rhino and to AutoCAD and Rhino, therefore. But one thing that you should be careful about is units, that we're working in inches. That's an important thing that you should share with later on in Rhino. It's an inch world. This is an inch world. And then you go to solids, and there's a difference between polymesh and ACIS solids. Think of polymesh as the great opportunity to 3D print something, but it's going to be full of triangles. Messy, definitely not cool for laser cutting. So for laser cutting and in general, I would probably say ACIS solids. That's going to be a heavier file, but you're gonna be able to work with it a bit better. Just say okay, next. You save it wherever you want it. And I'm gonna do 2 exports, so you see other possibilities of the export option in Revit. I'm gonna go to level 1, and I'm also gonna export this. So export DWG. So notice that here you see the plan. You don't need to go necessarily to solids because it doesn't really matter. You're taking a 2-dimensional, so you just need to know the inches. And it's going to be called for plan level 1. Say next, and I'm going to do a DWG. I'm going to be opening AutoCAD as well. Possibilities. In Rhino, You open new. Before you do anything, you make sure units are the ones you want. Otherwise, don't make any mess. So inches, feet and inches. That's the language of Revit. So you do that, and then you say open, just open or import. I think you will do the same. You can open directly DWG, but probably import better because of control of units. So we have the 3D view. Say open. It's going to open up a window of what things you want, blah, blah. You're going to refresh this, yeah. And just make sure those two are the same. The model units are the layout units. What does that mean? That means that when this thing comes in, it's going to be scale 1:1. So it's the real thing. And when you say, okay, it might take a little while if it's a complex model. Meanwhile, we can go to AutoCAD. So AutoCAD, the same. Control O, you select the floor plan, open. Now I open the DWG, so the units should be whatever it came from Revit. I didn't import it. Okay, so I just opened the DWG because I'm dealing with AutoCAD. So just make sure that that's inches, drawing units, are you good? Zoom extend, and you can see the stuff that is going on here. If I go to layers, LA, enter, then you can see how the layers look similar to the categories in Revit. Revit does not work with layers, works with categories. So probably let's talk about those things. This is the import. Notice how the section box is there. You might want to hide it. You didn't want that, so you can delete them now. You hide the layer. The layers are the same as in AutoCAD. So they go by color, and you can they go also by category as in architecture, structure, interior walls, et cetera, et cetera. So they have the first letter is pretty much the logic of those. Okay.
Pardon me for the dumb question. What is the purpose of transferring everything to AutoCAD and
Well, I think it really depends on what you want to do. I think knowing how to do it allows you to have more tools for you to use them later on. You could potentially do most of the things in Revit, but that's the point. When there's an actual moment where you say, I can't do this in Revit, do you get stuck? No, because I taught you, or will taught you probably much better than I can, that you have other ways to work on that in AutoCAD, in Rhino, et cetera, et cetera. So knowing how to go to other softwares and back, I think it's probably the crucial question of nowadays to be skilled. Yeah, each program has its own forte, or it's like stronger in some things and not other things. But I think Revit has managed to get to be in a point where most of the things can be achievable, especially when you're dealing with standard items or parts of projects. The second you get a little weird, Revit might not answer or might not be able to do it. So it's good to be able to take it, for example, to SketchUp, to take it to Rhino, to take it to other softwares. By the way, to SketchUp will be similar translation. So for example, well, we're going to take probably advantage of how the stairs are very easy, but I'm sure as an interior designer, you're wonderful, want something slightly different, picky, unique in your stair, and you're going to just hit the wall with Revit. No, but maybe you can use the Revit, you do a stair on a space with, the basic landing, and then you take it, only the stair, you can take it to Rhino, put it there, and then add your railing, or I don't know what it is, but there are ways that you should be able to work, across different platforms. This, for example, was mostly to talk about laser cutting. Now, Revit is not a place you can do it. So Rhino is probably one of the best out there in terms of digital fabrication. I mean, there are other ones, but Rhino is a good one. So that's why we're coming here today. Okay, so notice how there are walls and there are things and there are stairs, etc. So I'm just going to talk about the general basic rule of laser cutting. Well, laser cutting, you have done it in the past. You can do it in Illustrator. You can send to the laser cutting machine a vector-based drawing. No, that could be in Illustrator, but it could also be in AutoCAD, in Rhino, etc. As long as it's two-dimensional set of lines that they're inside of a rectangle, which is the framework of the laser cutting space, which you have probably the template. Do you? You probably have the template.
Remember what those departments were, and I think I could go back to what I was.
Well, what I would do is just I would go to and say TWK laser. I hope it's in the web. Otherwise, the Drake, which is our colleague here, is in charge of the fabrication complex. So basics of laser cutting, blah, 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 blah. See, you can see an image. You can do this. You can do that. Preparing your file. Well, do this. Don't do that. Are you crazy? Don't do this. The laser has a max size of 18 by 32. Materials. Well, you can definitely do plywood. You can do paper and so on. But do not do this because you burn the house. File types. You can do PDFs. Those are vector. You can do AutoCAD, Illustrator, and others. Practicals. Do this and not do that. Download, blah, 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 the Laser Lab schedule, just in case you want to know when and how. But you haven't, I thought you did laser cutting a little bit with Martha, no? Anyway, this is a great opportunity for you to laser cut. So you need I would search for the template, but you know the dimensions, so that's pretty much, where is it? Here, 18 inches by 32 inches. So what we're gonna do is Rhino, a rectangle, and we're gonna do 18 inches by, what was it? 32 inches. So I am rectangle. 32 inches. 18 inches. See? So cute. If you're not sure, you always can go with drafting and you can create a little bit of a couple dimensions, no? So you can say to make sure that that's precisely the thing. You can change that. That's correct. You can have that. Now, why? Anybody can tell me why this is so small to this?
So one-to-one.
This is one-to-one. So one of the first things you might want to do is select the world of things and scale it. Scale. Center point, whatever, 0.000, whatever calculation of your scale that you're looking for, or reference scale. But you need to scale that to the scale of your physical model. Okay. You might need more than just one panel. I don't know what scale you're working on. Okay. So scaling process is fundamental. Now, What goes inside of this rectangle is just closed polylines that the laser goes through and cuts, no? So we need those closed polylines. So you need to think of, well, how do I create those polylines? Well, maybe you want us to say things like, for this floor, move it here. And for this other floor, I need a polyline that goes along this space. So how can we do that? Step number one, it's flow. Number two, I have this plane and the rest I don't care. Duplicate edges. Well, there are different things that you can do here, another thing, but if you go to what is called the line to curve type of setting, so there's the duplicate border, duplicate edges. This, what it does is that in a surface, you can extract lines from it. Yeah, so maybe in this case, duplicate border makes more sense. You select this guy, duplicate, and what comes out of it is basically the line work. But you can say duplicate edges and select the whole thing. And then basically it's the same thing, just selecting a bunch of edges versus selecting one surface that gives you the profile of it. Probably makes more sense to duplicate border. I select that one. So maybe, but I'm saying it's plot before, so you can have only the surface that is above, and then duplicate border, and then you get that profile, no? So there you go. This is one thing that we definitely want to laser cut. It's another thing we want. How do we take them? Well, or you go to the top view, and obviously this is not the scale that we're going to be working, so yes, it doesn't fit in the thing, and you, unless you want a very big model, then you might want to chop this in two, and you do a laser cut of one piece and another one and connect it. But I'm for the sake of this thing, I'm going to actually make it even smaller, otherwise let's imagine that's the scale, no? So then you take those elements and you place them inside of the rectangle. Are they correct? Well, I wouldn't be so sure unless I go to the front view and see where they actually are. They're actually floating in space. So we get depressed and we don't continue anymore. Notice how they're floating. So there's this command. By the way, I didn't select the round thing here. There's the command called project to C plane. Sorry. If you select things that are floating and you want them to come to the floor, there's the code thing, project to C plane. C plane, remember, is the XY plane, which is basically the grid plane. It's going to ask you, do you want to delete? You probably want to say yes, and it just goes down to them. Or you could always just put them all horizontally in appearance and select export to Illustrator, that will go down, but you want to be careful. Now, there's best practices in the web, as in how do you do this? What I would recommend, and I think that's what Drake suggests, is that you don't put it exactly on the edge of the rectangle, that you give yourself, I think it's like a 1/2 inch margin, and that you do that for the in-between pieces as well, so you don't put it right next to it. You might want to put it like 1/2 inch or something. So there's a bit of a distance between each of the cuts, because when the laser cutting goes through, especially in some materials that are thicker, it burns. So it's creating this kind of a shadowy quality. So just keep some distances in that sense. Okay, so just continue that thought. Again, let's imagine this is another one. You can't, by the way, how do we laser cut a curve partition? a good point, yeah. So how can we use Rhino in any helpful way? Let's try something here. Well, how big is this plane? What we can do is also explode this. We can select this one and extract the borders. No, so the borders are those. We can explode this, select this curve, and that the dimension of that curve unfolded is the dimension of the laser cut piece. That then you score so you can embed it. You will score it on the side opposite to the bending opportunity. So again, I select this. What is the dimension of that? I can go to details. It should be here. Radius, center, angle, blah, 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 blah. You need to know the dimension of this. I think there is a command name. Nothing to do with. Yeah, it's also a circle. You can do it in plan as well and just get that dimension. But you will get that and you will have a rectangle and then you will take it inside of, sorry, inside of the item here. You will put it, distant from the other items, and then you will create typically it's a hatch. You select the boundary, and there are different types of hatches. Maybe you want to do the hatch one, which is line, and then you can scale it a little bit if it's bigger, smaller. But definitely we want a vertical, so it bends in this direction, so you can rotate it 90 degrees, maybe a little bit bigger. And you can just say, okay, to that. You can even explode it, I believe. And then assign those lines, maybe, oops, to a particular layer. Now, let's say score, right click, and then this could be particular color. So for that, we need to see the basics of here, vector scoring blue. Okay, so we need to use the blue, which is not that color, it's actually blue. So 0.1 point stroke path, vector only. So basically, if you leave it blue, vector scoring, you should be fine. What does that mean? If it's blue, the machine will say, I'm not going to cut through. I'm going to just leave a mark, just cut a little bit. That means that when you take this plane up, you kind of bend it without having any cut in the middle, no? Does that make sense? Scoring is not only great for bending, it's also great for textures. If you're doing a more kind of a detailed model for the floor textures of the material or a wall, so you could start adding kind of a sensitive, more information with your laser cutting process. So it's a wonderful thing. Now, black is engraving, scoring, maybe, sorry, for textures on walls and floors, maybe it's engraving, makes more sense, and cutting red, okay? Engraving is more of a fill hatch. So for example, yeah, if you do a text here, then this will be engraved, okay? You can also have that as a cut, but then you can hatch this or leave it as it was before with the fill. Because it's black, that will be engraved. So what is engraved is basically going through the whole area as if it was almost like a printer throughout the whole thing. It's just removing the first layer. So you're engraving, you're creating a texture out of that could be also nice of creating patterns or whatever, but this is more scoring. This is more engraving and anything red. So that would be this will be cut. Okay, engrave, cut, score. What I would do is a text, and by the way, you might have many do this and that type of comment, and you can put that outside, and it's a note to those working in the laser card. Just don't do this and do that. Be careful with that, and please let me know. Blah blah. So there's all these things that they pay attention to. You can also signal the material that you're working on. You're gonna have to bring the material, you put it there. It has to be of this size at least. You put all your pieces in 2 dimensions here. And sometimes it's easy to put the pieces back together. If it's a very complex model, you might need to give some hints. For example, write a text of whatever simple type and say, let's say a code like floor 1. If you have 1,000 floors, I would probably do that. Loading, so it doesn't take so, or just like that. So, so that could be something that comes from the, like, oh, floor level 1, so this is the one that goes here. But maybe floors in our case is not okay. But if you have many partitions, it might be tricky sometimes to know which one is which. I don't think in our case it's that necessary because it's a relatively small project, but I think it's often necessary in bigger, larger projects. Okay. So it's a little bit slow process of exploring and extracting the borders and then collecting them on the surface of the laser cut. There's no magical, everything is done for you, unfortunately. Even though Grasshopper will come in and help in terms of exploring all of these surfaces, extracting the border of all of these surfaces, taking all of these borders and place them in an organized way into the panel. That can be done in Grasshopper, for example. But you will need to select the surface that you really want and embed them into Grasshopper and do the whole process there. Yeah. So Grasshopper could definitely help out with a more automatic process. I would recommend it with very complex models, but with a interior design model like this one, I don't think it's necessary to do your exporting process carefully and go for it. So that's laser cutting. I mentioned that you can bring a plan from Revit, obviously, and therefore you can take it into Illustrator with all of the layers, no problem. So you can beautify those. We talked during the last project about the scale issue. So this is 1:1. So you will go to layout 1, you create a paper space, and then you can take it to Illustrator, you clean it up. So that sounds like a deja vu for all of you, but hopefully by doing it again, stays with you forever. The video is going to be crazy, so let me actually stop that video.